Hello, good morning everyone. Am I audible? Hello. I hope everybody knows that now we'll have our class 10:30 because Vishwadip sir said he'll take in the second half, so I thought I'll take this class now. Mm. Others they know or not now we're having class. Um, Shared in the group. We had done till we were doing the gantry girders, but till which portion did we complete? Anyone help me with this? We have this. till where we have completed. Did we do till the sections? We were selecting the sections, I guess. Um, Hello. We have selected this section 600 and ISMU 600 and ISMC 300. This is 300. Did we do this? The neutral axis part. Did we do this? The neutral axis? The CG of the combined member, this combined gantry girder with an I section and a channel section. How did we? Hello, good morning everyone. Let me start. Yep. Yes. Did we do this section? Did we select this section for the gantry order, the ISMV 600 and ISMC 300? Okay, then I think we'll start from here because I think you people also are not remembering. So this is, you see here, when we were designing what we had done previously, we had calculated the section modulus. We had calculated the required section modulus. That means this much section modulus is required for the loadings which we have calculated. So we have calculated this or the loadings, etc. Whatever. So for this loadings and for this moments, the section modulus that is required to resist those is this one which we have calculated here. So now on the basis of this section modulus we are going to check whether our section which we have selected here for the loading, which is an I section and the channel section here, is it okay or not, which it can resist or not those kinds of loads and moments. So this is your built-up number here. This is your channel section. This is your I section here. going for okay. See here, this is the I section which we have considered. Here, this is the I section and this is the channel section which we are considering. This was our 7.6. The thickness of the web was 7.6 here. Then we had the CG of the channel section 23.6 mm. Then we had the thickness of the web which is 12 mm. We had the depth of the eye section is 600, so half of this is 300. I think, okay, then we know the moment of CG, that means the CGs of these members, like the eye section distance is uniform, and so therefore its CG is at half a distance from the 600 to 300 here. But for the channel section, this is our CG from the edge of the web, right? So but we are forming a gantry girder now, so for that we have to find out the CG for the entire built-up member with an I section and a channel section. So y bar is equal to how much? A1 h1 plus a2 h2 by a1 plus a1 is what you can see here, the area of the ISMB, the standard median beam, this one, and A2 is our area of the channel section. This one, the area of the channel section. We have considered this to be 2 and this to be 1. The I section, the channel section to be 2. Now, what we have to do is A1 H1 plus A2 H2 by A1 plus H1. So what is with H1 for this entire I section? Not entire, this for the single I section which we are considering to be the first member. H1 is what? H1 is the CG of the I section, and that we know from here it is 300, half of the I section depth out of 600 it is 300. So therefore this is 300. This is 300 here. And then we have this is the area A2. And what is our H2? H2 is the CG of this channel section from the bottom. So from the bottom what it can be? It will be this 600, this total 600, this total 600, 600, plus if we do this thickness 7.6 of the web, minus if we do this CG of the channel section, we will get our this distance which we require now, which is this one from here, this distance. This distance is known as what we have done this 600 minus this, sorry, 600 plus this 7.6, the thickness of this web of the channel section, minus we have done the CG of the channel section, so we got the CG of the channel section from the bottom of the built-up member. Okay, so we got our y bar to be how much? 364.21 mm, which is this distance. This one, this is your, this is what? This is your CG of the combined CG of the entire built-up member. So, this built-up member, which is acting as a one member, like it is a gantry girder now. So, what is the CG of this entire built-up member? It is this one, y bar, which is 364.21. Okay, once we got this is from the bottom of this is from the bottom. Now we have when we once we know the CG of the entire built-up member, this entire built-up member, what we can do, we have to find out the moment of inertia. So moment of inertia of this along this z-axis, moment of inertia along this z-axis. This is the z-axis along this axis, and moment of inertia along this is your z-axis. This is your y-axis. So we have to find out the moment of inertia about this z-axis of the built-up member and the y-axis of the built-up member, and we will have what we can find out the moment of inertia. Then finding out the moment of inertia, after finding out the moment of inertia, we can find out the system. We'll find out why. We'll find out after. Now let's find out the moment of inertia about z-axis. The moment of inertia about z-axis will be how much? The moment of inertia of this I section and the moment of inertia of this channel section. This will be how much moment of inertia about z-axis and the moment of inertia about y-axis is to be calculated. Okay. So the moment of inertia about z-axis will be how much? Moment of inertia of this I section and the moment of inertia of this channel section. So that is nothing but here you will see Iz, that is the moment of inertia of the I section, and the moment of inertia of the number 2, that means the channel section. And here we have plus A1, H1 square, A2, H2 square, H1. Now, what area we know it is the area of, this is the area of the I section, this is the area of the channel section. Now, what is your H1? H1 is your distance from, if we are considering this, 300 H1 is nothing but here this here H1 also you can write it as R1. So it is nothing but the distance between the V. This is the I section here. This is the I section. This is the channel section. So here you know this is the H1 here is the distance between the CG of this I section and the CG of the entire built-up member. So you see here IZ is how much? Iz, the moment of inertia for this I section is how much? Given to you here 91813. So here if you see 91813, then area A1 meaning the area of the I section. I section's area is 15621. Here it is 15621. Then we have r h square. What is the h square? H square is the distance between, now because since we are considering the first member which is your I section here, so the h1 will be how much? H1 will be the distance between the CG, this is the CG, this is the CG of your I section. So this and the CG, this was the CG of the entire built-up member. So the distance between these two is your H1 square. So how much is that? That will be this 364.21, which is the CG of the entire built-up member. That if you subtract from that the 300, the half of the depth of the I section, what we'll get? We'll get this, which is the H1 square. Okay. So H1 square we got here 364.21 minus 300 square because H is in. Now coming to this portion, which is your for the this section number 2. If I give it as number 2, this suppose this I section is number one. So what will happen now for this entire section? So for this, what will happen now? I Z2 will be how much? That is here you will see I Z2. Okay, one more thing here, right? See here, if I show you for IZ2, they have taken the IZZ to be 15621. Oh, sorry. Okay, so here it was IZ1 plus A1 H1 square, this much. Now, A2 for this portion, the second portion, that is what the channel section, what is the moment of inertia about Z axis? IZZ plus A2 H2 square, right? And what is your IZZ here? Your IZZ here is this one, 310.8 into 10 to the power 4, which is, you see here, this is the properties of channel section. You see here, this is how much IYY is 310.8 into 10 to the power 4. But you may think that this was the Z section, okay, Z axis. So we should have taken the moment of inertia about the Z axis here, but you will see here this one. I have discussed this thing. So this was the channel section. If this channel section is in this way, then this is the y-axis, this is the z-axis, right? This is z-axis, this is the y-axis. But in this particular builder member, our channel section is placed in this way. So now this portion, which is our y-axis, it is this side. This one is our y-axis. This is our z-axis. This one, z-axis. So that's why what we are doing for this entire delta member, we are considering the z-axis. For this entire delta member, what is the moment of inertia about z-axis that we are trying to find out. And so for the I section, it was this only. For the channel section now, along the z-axis, what this one, this if you see this channel section now, it is placed here from here to here. This one. Now you see here along the z-axis of the entire builder member, z-axis is this, and moment of inertia about y, since this channel section is in this way place, so y bar y-axis is considering, so we are taking the moment of inertia about y-axis here for finding out the moment of inertia about z-axis for the entire builder member. So this one, that's why we are taking the IYY value. Okay. So IYY we have done, then A2. A2 is same, from here 4564, the area of the channel section. Then we have H1 square. Now what is the H1 square of this particular channel section? H1 square here is your distance between the CG of this, CG of the entire built-up member, this one, and the CG of this, that means this value. This is the CG, this one is the CG of the channel section from the edge of the web. So now, what is your H2? What will be this distance from here to here? How you will calculate this? What we can do is, if we find out this value, this from here to the this CG of the entire builder member, how much that will be? 364. Sorry, the 600 from here to here, the from top to bottom of the I section, 600 minus if we do this CG of the built up member, this one 364.21, we will get this distance, this one from here to till here. Okay, so that distance, this one, this distance, this distance is this total 600 minus this distance 364.39. If we do, we will get, I think, this one 243.39. Okay. So if we do now what? The total this 600 minus this 364, we will get 243.39. So now we need this distance from here to here, we need this distance. So we can subtract this portion 243.39 minus, if we do this distance which we know from the CG of the channel section from the web, this one 23.6. Oh, this 243. Okay, I'm sorry. This one is actually, where is my, okay. So what is your this distance? CG of the channel section and the CG of the build-up member. This distance you'll get by 600 minus this. You'll get this. So this plus this one, thickness 7.6. Then you can subtract the CG of the this one channel section 23.6. Okay. So I can so I am talking about this 600 minus 364.21, 364.21, that will give you 235.79. That means this portion is 235.79. Now this plus, if we do this entire thickness of the web 7.6, how much we can get? We can get this to be 243.39. Okay. So now from this entire 243.39, yeah, so that will give you this 243.39 minus, if we do from here this CG of the channel section 23.6, we will get our distance between these two. This z-axis of the entire build-up member and the z-axis of the channel section. Okay. That is how much? That is 219.79. Okay. Understood this? This one, the CG distance between these two green lines, these two green lines is how much? 600, this total 600 minus this CG of the built-up member will give you this, plus we will do 7.6, then we got how much? Minus 23.6 will give you this distance, whatever it is. Now you will see again here, this one. You can find it in either way, whatever you want, however you want to find out. You just have to, I have done in this way, but you can calculate in the other way. You can calculate it in the other way, but this must be correct. That is the distance between the CG of the entire build member and the CG of the whichever member you are considering. Next, now I y bar. We have y I y y. I z z is over the moment of inertia about z axis. I y y is already mentioned to us. I y y this, and I this is, so I z z is along our y axis. This one I z z. So I z z is this side. So 630 6362. See here, this one 2651 6362. 651, 6362. So we got our moment of inertia about y-axis, right? So these are your moment of inertia about z-axis and about y-axis. So once we know the moment of inertia about z-axis, y-axis, we will calculate now the plastic calculation of the plastic section modulus. Okay. So if I show you, let me make it one. So here you see, this is your gantry girder here. Suppose this is your 300, half of the I section here. 300. Now here you see here the neutral axis will divide the member into two equal areas. Okay. Now, what are those equal areas? One is at the top, one is at the bottom. Okay, we will consider this area AS. We'll take the AS to be the area of the I section and the AC to be the area of the channel section. So the total area will be how much? The total area will be AS plus AC. Now, if you see the top and the bottom, equating this to, if we get what we'll get, AS by 2, that is this area, right? We are considering what AS plus AC, that is the area of the I section area. Okay, the area of the I section and the area of the channel section. So at the bottom portion, this bottom, since your neutral axis is dividing both the that means the total entire filter member into two equal area ratios. So this is the bottom portion and this is the top portion. We can equate these two because you are equal with the help of this neutral axis. We are dividing the entire building member into two equal areas. So these areas are considered AS is equal to AC. We are above the neutral axis we are considering. At the bottom portion, these are at the bottom, these are at the top. So at the bottom, if you see below this axis, Z axis, so below this Z axis, one more thing. What was our now you see here, this is the bottom portion AS by 2. AS by 2, AS was what the area of the I section. So this is your I section. Area AS by 2 is this. AS by 2 plus we will consider this to be TP, thickness of the plastic section modulus here. This is thickness here, thickness of the web TW. Okay. So we have here at the bottom of this plastic section will be how much? AS by 2, the area of the I section, half of the area of the I section, plus this area obviously, because this is your axis now. We don't know how much is this axis, how much uh, at a distance of how much is it from the this 300, that is the CG of the I section. We don't know. So we are assuming this to be dp, okay. And so area will be how much below this line, below this axis where our entire builder member is divided equally. Here at the top also it is same area, here at the bottom also it is same area. So this axis is dividing that. So this distance from the CG of the I section is how much dp, the thickness of the uh, section here, the plastic, how much it is dp, we are considering it to be dp. So the bottom portion area of the I section below this axis is how much area of the, obviously the half of the area of this I section, half plus the dp, this area is how much dp into tw. So dp into tw. Then at the bottom, at the top portion, it is how much area. This area, half of this area, I section's half area minus this is the half area of the this one. This entire thing from this line is your above. Okay, so this will be how much? As by 2 minus, we have to subtract this because already we have taken this from the bottom. So minus dp into dw plus this one AC, area of the channel section. Okay, so this can be cancelled out, As by 2. From here this equation we will get dp is equal to AC by 2 into dw, where dp is equal to 190.16, because area of the channel section we know, thickness of the web also we know from the properties. See here, thickness of the web is 12. This one, area we know, AC area of the channel 4564. So we can write here. So our DP value is, that means this distance is how much? This one, 190.16. This is equal to 190.16. So we can calculate after this, when we know this distance of the plastic section axis here of the builder member, we can go with the calculation of plastic section. Okay, below and above this axis, below and above this plastic section axis, okay, where the area is divided, above and below it is divided, the entire area of the builder member is divided equally. Okay, so because we are finding out the section modulus of the entire builder member, and we have to compare it with the section modulus which we have calculated here. This one, this one we have calculated here. So obviously, after selecting the section, you have to select your section in such a way so that your plastic section modulus is greater than this, such that the section which you have considered, that will resist your all the that will resist all the loads, all the movements, and okay. So, but if it is less, after selecting your this section, I section, your ISMB and ISMC, after selecting this, after selecting this, when you will find out the section modulus, that will be your design section modulus. That means how much you have, um, how much you are getting the section modulus for this when you are using these two sections, ISMB 600 and ISMC 300. So we are going to compare that section modulus with the section modulus calculated. So the section modulus is given by how much? Summation of A y bar. Summation of A y bar. This is the section modulus below the z-axis. Okay. Now this is how much? Z axis is given by summation of a y bar. So how many parts are there? You see here, this axis we have to consider, right? So how many parts will be there? There will be at the bottom, there will be two parts, this one, this portion, and we have the uh, flange portion. Okay, so what is your summation of a y bar? It was summation of a y bar, this one. So you have your area here. The area of this is how much? Okay, I have this was 210. So here this was 210. This one. Width of the flange is 210. So 210 into this one. This is your 20.8. Okay. See here 20.8 we are having. The properties, if you see, you will get this one. Thickness of the flange 20.8. So this is 20.8 here. So this we got the area. Now y bar will be how much? You see here, for since now we are considering this member, the y bar of this particular portion will be how much? This is 190.16, this is 300. So total from the bottom till this z axis will be how much? 490.16. So 490.16. If we okay, this y bar for this particular this member here, for this member below the z plastic section axis, we got how much? This is the area for this, and we have y bar. Y bar is the distance between the this axis of the built up member and the CG of the member which we are considering. So we are considering this member, so that means this distance we need this. So we need this distance. So this distance how you are going to get? We are going to get this 300 plus this one 190.16, this total 490.16 minus if we do this portion 20 by 20.8 by 2, we will get this distance, right, which is the y bar for this particular member. Similarly, now this we got. Now we have another member below this z-axis, which is this portion, this one. Now what is the area of this? Area of this will be how much? This 300 plus 190, 490.16. If we subtract from 490.16 this 20.8, we will get this distance, obviously, this one. Distance and TW we already know. So it is 490.16, 490.16 minus 20.8 into your this TW, which is 12. This one is 12. Okay. TW is 12. So this is the area here. Now what is the y bar of this particular section? This axis and the axis of this member is your y bar. Okay, so that will be how much now? So that will be this 490 from here to till here. 490.16 minus if we do this, obviously then divide by half of this number. Half of this is your CG here somewhere. CG of this. Okay. So we will get over here section modulus, this one. Below the z-axis, we will get this. And the section modulus above the equal ratio, how much? You see here in this figure, if I show you, there are three members above this axis. This one is this, another one is this, and the third one is this. So, if we see for the channel section, let us consider the first channel section here. So that will be how much? AC area we already know from here. This one AC 4564. Here you can see here this is the I'm considering now this to be the first. We'll calculate this first. So this is the area AC we know already. Area, this area into y bar is what now? Y bar is this distance from here, this z axis to the CG, and the CG of this channel section is somewhere here we know, which is this is CYY.